Okay, so today, this section, we're talking about the same thing that we talked about last section. So this is day 2 of fourth one. So we're still talking about midsegments of triangles. However, in this assignment, we are going to have to prove 3 things for each example. We're doing 3 examples, and in each of those examples, we have to prove 3 things. So number 1, we have to prove, like for example, using this shape up here, we have to prove that D is the midpoint of AB, and then we have to prove that F is the midpoint of BC. We would have to prove that the midsegment, when I connect those 2 midpoints, is parallel to this third side. And we'd also have to prove that it is the midsegment is half the length of this third side. So for each example, we're going to do all 3 of those things. So first thing, example 1 that I'm going to do is I'm going to graph, let's use blue. I'm going to graph these points that they give us. So G is at -7, -1. So I go left 7, I cannot see this. And then down 1. -5, 5 is H, so -5, 1, 2, 3, 4, 5. And then finally I is at 1, 3. So right 1 up 3. So it creates this little triangle right here. So this is G, H, and I. So step 1 says use the midpoint formula. So they give it to you right here. So the midpoint formula, basically you're just finding the middle of each of the lines. Let's use green. So you could use the midpoint formula like this. So x1 plus x2 divided by 2. So G and H, the x values were -7 and then -5 divided by 2. Oops. So that'd be -12 divided by 2 is -6. So our x value would be -6. And then the y's are -1 and 5. So -1 plus 5 divided by 2 would be 4 divided by 2, or 2. So our midpoint is -6, 2, which is right here. So that's one method to find the midpoint. Another one is what I'm going to do for H and I. So the height between I and H, to get from I to H, I would have to go up 2. So half of that would be 1. So I'm going to go up 1. And then to get from I to H, I have to go to the left. So I go 1, 2, 3, 4, 5, 6 to the left. So half of that is 3. So, and then I'm going to go left 3. So I go up 1, left 3. So 1, 1, 2, 3, and that's the midpoint. And I could do the same thing with G and I. So 1, it's kind of hard to see on my screen here. Hopefully you can see it better on yours. 1, 2, 3, 4. Then 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go down 2, left 4, 1, 2, 3, 4. So whatever the distance is horizontally between the 2 points, go half of that length. Whatever the distance is vertically between the 2 points, go half that length, and that's how you get to a midpoint. So the midpoint of GH is at -3, 1. So you could fill in all this information if you wanted, but I'm not going to. The midpoint of IH is at -2, 4, because we went left 2 up 4. And then it says label this point K. We had to label this point J and draw a segment between them. So JK is our midsegment. So step 2, we need to compare the slopes of JK and GI. So if they have the same slope, that means they're parallel. So we're trying to prove 3 things. So that the midsegment has 2 midpoints, that the midsegment is parallel to its third side, and then also that the midsegment is half the length. So we're doing the second thing right now, which is proving that they're parallel by finding this that they have the same slope. So the slope of JK, it goes up 1, 2, 3, and right to the 1. So the slope of JK is 3, or 3 over 1. The slope of GI, so 1, 2, 3, 4, 5, 6, 1, 2. So it goes up 6 over 2. So 6 over 2, which does equal 3. So they do have the same slope. They both have a slope of 3. Since the slopes are the same, JK is parallel to GI. That's what we need to write right there. And then finally, we need to prove that they have the same distance. Or excuse me, we need to prove that the midsegment has half the length of the third side. So we could use the distance formula here. Or what I like to do is I just like to use the Pythagorean theorem. So I'll do the distance formula for one, and then I'll use the Pythagorean theorem for another. So I'll use the distance formula for JK. So the two x values, J is at, where was J? It's at -3, 1. That's -3, 1. K is at -2, 4. So -2, 4. So the two x values are -3 minus -2. When I have a minus minus, that turns into a plus. That's all squared. And then the two y values are 1 and 4, so 1 minus 4. So -3 plus 2 would be -1. So -1 squared is +1. Plus 1 minus 4 is -3. -3 squared is 9, +9. So +9. So that'd be the square root of 10. So I'm going to use the Pythagorean theorem for the second one so you can see both ways. So to use the Pythagorean theorem, I need to make a little right triangle. And I need to find the length of the hypotenuse here. So I can count the horizontal length as 2 and the vertical length is 6. So a squared plus 2 squared, or a squared plus b squared equals c squared. So 36 plus 4 is equal to c squared. 36 plus 4 is 40. Take the square root of both sides, so c is equal to square root of 40. So if you remember from Unit 1, we simplified these things. So I know that 4 times 10 is 40, and I know that 2 times 2 is 4. I could break down 10, but I'm not going to need to do so. Got a pair of 2's though. One goes away, the other one comes out. So 2 root 10 is my answer. There we go. 10 does not want to work. So notice that GI is twice as big as JK because 2 times radical 10 is twice as big as just radical 10. So I just proved that the midsegment is half of its length of the third side. So since GI, oops, wrong letters, JK is equal to half GI, JK is equal to half GI. I think they wanted me to write something else there, but that's the main idea. All right, so that's what we have to do for each one of these examples. So example 2, I'll do this really quickly and then I'll just put the answer for example 3 up. So the coordinates of ABC are A is 4, 6, B is 6, 0, and C is 0, 0. So connect those points. So D is the midpoint of CA. It would help if I wrote the letters. So this was C, A, and B. So D is the midpoint of CA. So CA goes up 6, so I go up 3, and then right 2. That's point D. Point E is the midpoint of CB. So half of the length from 0 to 6 would be 3. So that's our mid-segment. So now we need to find those three things. So we need to find if they are parallel. So the mid-segment has to be parallel, so they should have the same slope. So, oops, erase that. So DE has a slope of, I go right, or I go up 1, 2, 3, left 1. So up 3, left 1, so negative 3. And then AB has a slope of 1, 2, 3, 4, 5, 6. This one. 1, 2. So I go up 6, left 2. So that would be negative 3 as well. So they have the same slope. So we're good there. Step 2. We need to prove that the mid-segment is, we just did the slopes. Step 2, we proved that they were supposed to do the slopes. I did it backwards. Step 1 was midpoints. So you're supposed to use the formula, so switch these. It's my fault. So remember the midpoint formula. If you just count like this, that's fine as well. So you count up 6, half of that is 3, left 2, half of that would be 1. So I'm just going to draw an arrow, save us some time. And in step 3, we need to prove that the mid-segment is half the length of the third side. So DE is going to be equal to, I like to use the Pythagorean theorem. If you wanted to use the distance formula, that's totally fine. So this length was 3, this was 1. So I'll make my little right triangle here. So 3 squared plus 1 squared is equal to C squared. So we're going to get square root of 10 equals C. And then AB, the same triangle that we had last time. So 6 and 2, so 6 squared plus 2 squared is equal to C squared. So 36 plus 4, and eventually you'll get C equals 2 root 10 again. So notice that AB is twice as big as DE because we're multiplying root 10 times 2. So check that off. So example 3, you guys can do this on your own. I'll put the answer on the part 2 of the video. The length of the mid-segment and the third side of the triangle have to be related. The mid-segment has to be half. So half the third side.